Here are 3 drilled symmetrical balls. These are both jackpot, all jackpot solids, radical balls. They are symmetrical balls. Here are 3 different types of drillings. The same pin location, but different CGs. Now the perception out there with a lot of people is if I move the CG over here, I've moved the preferred spin axis in line. So they would think that the preferred spin axis would be 6 3/4 from the pin on that line with this one, 6 3/4 from the pin on this line with this one, and 6 3/4 from the pin on this one. I've heard about that my whole life. We're going to mark those spots where everybody thinks the PSA of this drill ball is located. Okay, there's one. Let's do another one. And then let's do a third one. Okay, let's get this 0, 6 3/4. Okay, so according to some of the fallacious reasoning that we have in the industry, how about that word, fallacious, okay? They would think that the PSA of these 3 balls is moved because we moved the CG. Well, what we're going to do is we're going to put them all on the determinator and spin them to find out where the PSA really is and see if this reasoning is correct or if this reasoning is a fallacy. Okay, first one we're going to do, one with the CG 3/4 of an inch negative. According to some of the perception I hear, that puts the PSA here. Well, let's find out where it is. Put the ball in the right direction. Spin it up. There's the PSA. Bouncing a little bit because we got holes in it, but there it is. That's just because the holes are hitting the drive bucket. Okay, so PSA of that ball is just left of the center line. It's not over here. Let's try the other one. Let's try this one. This is the one with the CG 3/4 positive, which wouldn't require a hole. Neither one of these would require a hole to be legal. According to them, the PSA is right here. Let's see what happens. I like to call this the reality of symmetrical balls. You will find the location of it, and you'll also notice that they spin up quite fast now. Okay? See where this one is. Okay? In my opinion, CG 3/4 negative, 3/4 positive, I think it's pretty damn close to the same spot when you spin them. Okay, so I guess that's not holding water right now. So let's see if we can find something that floats a little bit. That's just a little bad pun by me. Okay? Now we get the one that's got the CG kicked out 2.5 inches. One we will put a hole in to show you what's going to happen. Let's find out where the PSA on this ball is. Okay? Let her go. Near the thumb hole. I broke the pencil. That's where it's going to have to be marked. It's easy to break pencils doing this. Okay. Well, look at that. Look at that. And look at that. 3/4 of an inch negative, 3/4 of an inch positive, 2.5 positive. Guess where the PSA on all 3 balls are? It's so close to the same spot you couldn't tell the difference. So, I guess there's no reasoning to the fact that the PSA is between or at the end of the line from the pin through the CG on a symmetrical ball. That ain't true. We use it to get drilling angles so that we can either get the ball down the lane a little earlier, but that's not where it's going to end up. What we're going to do now is we're going to put a hole in this ball to make it legal. And let's see if that moved the PSA anywhere.